Hey class, Mr. Hanji here. For today's lesson, we're going to be taking a look at section 3.3, which is going to deal with modeling with functions. So for today's lesson, we have one learning goal, and our learning goal for this lesson is you will be able to write a function for a situation and identify the independent and dependent variables. So some problems are going to have us write functions, some are going to have us identify independent and dependent variables, and domain and range also is going to pop back in. So let's get off and rolling. Now, the input of a function is the independent variable, and the output of the function is the dependent variable. This is where the key statement comes in. The value of the dependent variable depends on the value of the independent. So, when we're going through and determining independent and dependent, okay, you have to ask yourself this: what depends on the other thing? There's going to be a variable or an amount, something that does not get changed or does not depend on the other, and that would be independent. It's not affected by the other variable. The dependent variable, in this case, depends on or is affected or changed by whatever the independent variable is. So, with that said, we're going to go through and practice some identifying independent and dependent for us today. All right, so let's go ahead and move this up. So this is kind of a pre-example. So our pre-example for this states that we need to identify dependent and independent variables in each situation. So our situation is, in the winter, more electricity is used when the outside temperature goes down, and less electricity is used when the outside temperature rises. Meaning, the colder it is, the more electricity you're going to use. So let's say it's negative 10 degrees outside. You're going to be using a lot of electricity to heat your house. Let's say it is 65 degrees outside. You're going to be using hardly any electricity because it's warmer outside and you don't have to heat or cool the house, yet it's at a nice temperature. So this just states, in the winter you're using more electricity when the outside temperature goes down and less electricity when the outside temperature rises. So our two variables in this case is electricity and outside temperature. So, does the amount of electricity depend on the outside temperature, or does the outside temperature depend on the electricity that you use? So you have to ask yourself this: does the electricity, the amount that I use, change based off the outside temperature, or does the outside temperature change based off how much electricity I use? In this case, the amount of electricity depends on the outside temperature. So, the amount of electricity depends on the outside temperature because electricity usage isn't going to change the outside temperature, but the outside temperature is going to change how much I use this. Outside temperature doesn't depend on electricity, but electricity depends on outside temperature. So my dependent variable is electricity, and my independent variable is going to be the outside temperature. And that is how we're going to go through and identify independent and dependent variables. So let's go through and practice a few more. The more you hear and the more you see it, hopefully the more it should click for you. So let's go to our next situation, which is going to state the cost of shipping a package is based on its weight. So my two different variables in this case is cost of shipping package is based on its weight. So cost of shipping and then weight is going to be my two variables. So does the cost of shipping depend on the weight of the package, or does the weight of the package depend on the cost of shipping? So does cost depend on the weight, or does the weight depend on the cost? Well, in this case, the cost to ship a package is going to depend on the weight. The heavier the package, the more it costs. The less heavy a package, the less it's going to cost. So that means my dependent variable is cost, and my independent is going to be the weight. Something to keep in mind, any time that we talk about an amount or a total or a cost, that generally indicates a dependent variable. Okay, anytime we talk about something total, whether it's total cost, total amount, okay, that is going to be a dependent. All right, last one. And I can keep this one up here. All right, the faster Tom walks, the quicker he gets home. So my two different variables in this case is going to be the speed at which Tom walks and then the time he gets home. So, does the speed that Tom walks depend on the time he gets home, or does the time he gets home depend on how fast he walks? In this case, the time it takes for him to get home depends on the speed in which he walks. Okay, the faster I walk, the faster I get home. The slower I walk, the slower I get home. Okay, getting home depends, or the time in which it takes me to get home depends on how fast I walk. So time is my dependent, and speed is my independent. Okay, the speed in which I walk doesn't depend on the time I get home. Now, you may walk faster if you have to get home by a certain time, but it's not going to change. The speed isn't determined based off the time it takes you to get home. The speed determines the time in which you get home. All right, so that is going through and identifying independent and dependent. So we're going to go through and use that throughout our problems for today. All right, so before we jump into example 1, we do have a little more terminology that we need to talk about for today. All right, before we get into example 1. If x is the independent variable and y is the dependent variable, then you can use function notation to write y equals f of x. Okay, so this f parentheses x reads y equals f of x. So this stands for f of x, where f is the name of the function, and then the equation in two variables describes the function. You can always use function notation to write it. Now, you may be going, what in the heck is that? Why, where, what? Okay, f of x, if it helps you think of it, is just a fancy way of writing y. Okay, know that y equals f of x, meaning if I had a situation where I said y equals, say, 2x plus 3, f of x equals 2x plus 3 is the same thing. All I have done is just switched out y for f. There's a whole basis for why mathematicians and why we even use this. And you'll kind of see it when we go through and plug in a number, because it's going to help us to know that when, x is 5, okay, f of 5 is whatever this is when I plug 5 in for x. So understand function notation is really just a fancy y y equals 2x plus 3 means the same thing as f of x equals 2x plus 3. But be aware, anytime they ask you to write a function, or when we're talking about in this section, it needs to be something as a form of f of x, or g of x, or f of h, whatever the variables they ask you to use. All right, so with that said, let's go ahead and take a look at example 1 here. And let me cover this part up so we're not confused by it. All right, example 1 asks us to identify the independent and dependent variables, write an equation and function notation for each situation, then use the equation to solve the problem. So our situation is a lawyer's fee is $180 per hour for his services. How much does the lawyer charge for 5 hours? So a lawyer charges $180 per hour. And then we want to know how much the lawyer charges for 5 hours. So if we're thinking about our independent and dependent variables here, I'm going to indicate that as I and D. My two variables in this case are total cost, so total amount, total cost, and my other variable in this case is going to be hours. Okay, the number of hours that you use the lawyer. All right, so does the total cost depend on the number of hours you use the lawyer, or does the number of hours you use the lawyer depend on the total cost? Again, I talked about up above that total amount, total cost, total whatever is always going to be your dependent, and the other thing is your independent. Okay, our total cost, the total amount in which we have to pay the lawyer, depends on how many hours in which we use the lawyer. Okay, the number of hours we use the lawyer doesn't depend on total cost. This is changed by this. This is not changed by this. So dependent is total cost, and independent is the number of hours that we use the lawyer. All right, so we've identified independent and dependent variables. We now need to write an equation and function notation for the situation. So if we have a lawyer's fee is $180 per hour, so if we need to go through and write a function for this, first thing, I need to identify a variable for hours. So I'm going to use H for hours. So to set this up, okay, I also need to know the total. Well, I don't know the total. That's my dependent. So we're going to set this up as f of h, because my variable is h, equals. Now, the only thing set up for this is it's $180 per hour. There's no initial fee. There's no discount. It's just $180 per hour. So my function is going to be f of h equals 180h. So this is my function. Now we need to use my function to go through and solve the situation for how much does the lawyer charge for 5 hours. So we're going to take that 5, we're going to plug it in right here. So that means instead of x, or instead of h, so it would be f of 5 equals 180 times 5. So then you're going to take your handy dandy calculator, and we're going to go through and do 180 times 5. And we end up with 900. So that means the total cost to use the lawyer for 5 hours is $900. All right, so that is how you go through and solve or do these problems for example 1. So you're going to go through and identify independent and dependent variables, set up a function. It's just like writing an equation. Think of this as like y equals 180x. And then you're going to plug 5 in for h and get your result at the end. So there are a few more examples like this, and that's kind of what we're going to take a look at for parts B and C. And then we'll take a look at example 2. Alright, so for part B, it wants us to do the same thing, where we are going to go through and identify, if I can find the B. Alright, there we go. Where we're going to go through and identify the independent and dependent variable, write a function, and then solve it for the situation. So our situation is this, that the admission fee at a carnival is $9. So admission fee at a carnival is $9. So to get into the carnival you pay $9, and then after you're in the carnival, each ride costs $175. So how much does it cost to go to the carnival and then go on 12 rides? So, a few things here. Let's go through and identify our dependent and independent variable. In this case, we have two different variables or two different things for this. Okay, we have total cost to go to the carnival, and we also have number of rides that you're going to ride. So, does the total cost it costs to go to the carnival depend on how many rides I ride, or does the number of rides I ride depend on total cost? In this case, the total amount in which I'm going to spend, or the total cost to go to the carnival, is going to depend on how many rides I ride. Okay, total cost isn't going to affect this. Okay, if I ride one ride, it's going to be a lot cheaper than if I ride 30 rides. Okay, so that means total cost is going to depend on how many rides I go on. So again, dependent is total cost. Again, anything that's total or amount is going to be your dependent, and then my independent is number of rides. The thing that can fluctuate without being affected by the other thing is your independent thing. Alright, so next I need to go through and write a function for this. So my function, we're going to use the admission fee at a carnival is $9. So my initial payment is $9. I don't pay that for every ride, yet I just pay that when I go in. So you would pay the person at the ticket booth $9, and then each ride is going to cost $175. So my variable here is going to be the number of rides. So I'm going to use R for rides. So if I'm writing a function, we're going to write this as f of r, because r is my variable. F of r is going to stand for the total cost of going to the carnival. It's initially $9 to get in. That doesn't change. And then it's $175 per ride. So then it's $175 r. So my function is f of r equals 9 plus 175r, $9 initially, plus 175 per ride. Alright, and then my situation asks for how much does it cost for 12 rides? So then we would take f of 12 and just plug that in for r. So it's 9 plus 175 times 12, which I just went off the paper. So I have f of 12 equals 9 plus 175 times 12. Plug that in your calculator, and we should get f of 12 to equal 30. That means it costs $30 to go to the carnival and ride on 12 rides. All right, so that is example 1b. Now, example 2c is continuing the same thing. It's just the fact that we have a different situation, and you would kind of run through the same thing. So for 2c, we have Kate is going to earn $7.50 per hour working at her job, and then it wants to know how much will she earn after working 8 hours. So you would have to go through and identify your dependent and independent, write your function, and then plug in 8 to figure out how much it is. To give you a bit of guidance for this one, for a reference, my domain is the total she earns for working, and my independent is going to be the number of hours in which she worked. Okay, because the amount she earns, the total of her paycheck, depends on how many hours she works. The more hours she works, the more she gets paid. The less she works, the less she gets paid. And then my function, I'm going to have this as f of h, h being for hours. And then it's $7.50 per hour. There's no $100 for the week or whatever, or that she lost anything or gained anything. So my function is just this. So then you would take this 8 hours and plug it in for h to figure out how much she earned. So I will leave that for you. I think you can plug it in and figure out for that. Okay, example 2 is going to ask us to go through and write each situation and function notation, and then find a reasonable domain and range for each situation. So we're going to have to go through and write a function and then find domain and range. We don't have to do independent and dependent variable for this one. All right, for example 2a, Marvin has already sold $20 worth of tickets to the school play. He has 4 tickets left to sell at $2.50 per ticket. We need to write a function for the total amount collected from ticket sales. So he has already sold $20 worth of tickets. He has 4 tickets left, and he's selling tickets at $2.50 a pop. So if I am going through and writing my function, it doesn't matter what variable you want to use for this. You can use t for tickets. Because t's sometimes look like plus signs, I'm going to use x for tickets. So I need to go through and write my function in function notation. So it's going to be f of, and my variable in this case is x. And we want to know, so my f of x stands for the total amount collected from ticket sales. So that means this stands for total. And how do we figure out the total? Well, he's already sold $20. And then he has 4 tickets left to sell at $2.50. So this is going to be plus $2.50x. He has 4 tickets left to sell, but we don't know if he will sell 4 tickets. So that's why this is going to represent the total. So f of x, the total amount he gets from ticket sales, he's already sold $20 plus $2.50 per ticket that he has left to sell. So if he sells 1 ticket, 2, 3, or 4, that's why we use x. So that is my function. Now, this problem talked about what is a reasonable domain and range. So remember that domain is my x values and range is my y values. Know that anytime we talk about the range, that's my f of x, domain being my x or whatever variable I choose is what I'm plugging in. Well, I have 4, or Marvin has 4 tickets left to sell. So, what's a reasonable number of tickets that he can sell? He could sell all 4 tickets. Could he also sell 1, 2, 3 tickets? He could. So, we have to consider all the reasonable situations in which he could sell, or amounts of tickets he could sell. Now, before we write this down, could he also sell 0 tickets? Could he sell no tickets? That is very possible. So that means we can use 0 also as our domain. So he could sell 0, 1, 2, 3, or 4 tickets. He only has 4 tickets left, so I cannot use 5 as a number in my domain. So we're going to stop at 4. Now my range is going to come from taking these domain numbers and plugging it in to my function. So that means I'm going to take 0, and we're going to have 20 plus 2.50 times 0. So when I plug that in, I get 20. If I go back in and I plug in 1, we end up with 22.50. And you're going to keep doing that for 1, 2, 3, 4. So we'll do that for the rest of these. So then we have 2. So we end up with 25. For 3, we have 27.50. And then if I plug it in for 4, we end up with 30. And that is how we're going to do example 2 for the rest of these. Now, for parts B, C, and D, it's kind of the same format where we have to go through and write a function, determine the domain, and then figure out a reasonable domain and range. Now, what I'm going to do is go through and write the different functions, talk to you about what your domain is. I think that you can plug it back in and figure out your reasonable range. You can always take a look at my completed notes if you need a bit of guidance. So let's kind of briefly look at parts B, C, and D. So for B, a telephone company charges 25 cents per minute for the first 5 minutes. And then a call plus a 45 cents connection fee per call. So that means when you call, it's 45 cents to connect and make your call, and then it's 25 cents for the first 5 minutes. Now, I'm going to use M to represent minutes. So my function would be f of M. It is 45 cents to make the connection per call. So the total per call starts with 45 cents, and then it's plus 25 cents per minute. Now, this is not talking about a monthly phone bill or, based off something. We're just talking about the cost to make a call. So I don't need to worry about having a variable on number of calls, adding this as 0.45c. Okay, it just wants to know for one call. So one call is 45 cents plus 25 cents per minute. Now, your reasonable domain, because it's for the first 5 minutes, if I'm not making a call for 0 minutes, then if I'm making a call for 0 minutes, I'm not making a call. So I can't use 0 in this case. And I want to know for 5 minutes, so it's going to be 1, 2, 3, 4, and 5. So that's my domain. My range is going to be taking 1 through 5, plugging it in for M, and figuring out what they are. So I will leave that part for you like we did up in A. plug in 1, 2, 3, 4, and 5, and for m, and then once you get those values, that's your range. All right, for C, it talks about the temperature early in the morning is 17 degrees Celsius. The temperature increases by 2 degrees Celsius for every hour for the next 5 hours. So we start with 17 degrees, and it increases by 2 degrees every hour for the next 5 hours. So if we go through and do this, my variable is going to be h for the number of hours, because we want to write a function for the temperature in degrees Celsius over the hours of the day. So my function is f of h. Temperature starts at 17 degrees in the morning. So 17 is going to be my starting point, and then it increases by 2 degrees Celsius for every hour from then on. So it's going to be plus 2h, and then that's going to represent the temperature in degrees Celsius. So it starts at 17 and it increases by 2 degrees each hour. Now, for the next 5 hours, that's going to represent our domain. So our domain in this case is I could start at the morning, my first hour, my 0 hour. So we can have 0 through 5. So it's me 0, 1, 2, 3, 4, and 5. And then my range would be taking 0 through 5, plugging in for h, and calculating. So it would be 17 plus 2 times 0, 17 plus 2 times 1, and so on. All right, and then lastly, for D, we have Tyler earns $8.50 per hour proofreading advertisements at a local newspaper. He works no more than 5 hours a day. Write a function for his earnings per day. So let's use h again for number of hours in which Tyler works. So my function for his earnings would be f of h is going to equal, he gets $8.50 per hour proofreading advertisements. There's no money added or subtracted from that. There's no initial amount he gets. So it's just $8.50 per hour, like the Kate problem. So that means my function is going to be f of h equals $8.50h. And then for my domain and range, my domain is going to relate to the number of hours in which he works. So if he works no more than 5 hours a day, well, he could work 0 hours, 1 hour, 2 hours, 3 hours, 4 hours, 5 hours. So my reasonable domain would be 0, 1, 2, 3, 4, and 5. So I'm not going to include anything more than 5 because he works at most 5 hours per day. So 5 is going to be my stopping point. We're not going to include 6 or anything more. And then my range would be by taking these numbers and plugging them into my function. So you do 0 times 8.5, 1 times 8.5, 2 times 8.5, and so on. So that is how we do example 2, and that is going to be our lesson for section 3.3 on modeling with functions. As always, take a look at my completed notes, and if you have any questions, as always, just ask next time you see me, or shoot me an email, and I'll be more than happy to help however I can. So that is it for your video today. Thank you for listening, and I hope you have a great day. All right, bye.